All right, so Chapter 1, like I said, a first program using C#, Chapter 2 using data. You're probably going to find that the editor that we'll use that is Visual Studio is much easier to use than whatever you used last semester. It's much more powerful than brackets. Anything is more powerful than Notepad or Notepad++. All right? It's color-coded, etc., and you'll see that as we go on. All right. I'd also like to get through Chapter 3 this week, which means by the end of this week, you will have written at least probably half a dozen programs. All right? If somebody told me by the end of this semester in 50 days, you're going to write approximately 100 programs, I would believe that. Now, many of them are going to be derivations of the same program. All right? Some of them will be brand new programs. Some of them we'll do together. Some of them will be assigned. Okay? All right. Then we'll get into Chapter 4, where we'll learn if statements and switch statements. Chapter 5, the same 3 loops we did in JavaScript, a for loop, a while loop, and a do-while loop. 7 and 8 are on methods. Probably the hardest 2 chapters in the book probably are 9 and 10. Okay? Because you can use C# as an object-oriented programming language. We didn't go over any object-oriented stuff last semester. We will this semester. Guaranteed. All right? Chapter 11 is on exception handling. Chapter 12 is on controls. That's actually funny because by the time we get to Chapter 12, you're going to know virtually everything that's in here because we'll have already used controls. All right? Chapter 13 is on events. Chapter 14 is on files and streams. This is a good book. The thing that keeps it from being a great book is the fact that the author, Joyce Farrell, does not talk about databases in the book. That's why I'm going to give you a whole database portion myself and then bring it back in so that you can see how to use databases with C#. All right? We're not going to go over the appendices, so if you go over them and you have any questions, you'll have to let me know. One thing with using VitalSource like this, if I come in and try to change my page size, the system gets real funky. It'll either take over the whole screen or whatever, which I don't like, but it does what it does. All right. I should mention to you also, just so you're aware of this. Where is it? I guess it's under Inside Rankin. People learn in different ways. What I'm finding as I go on is more and more people are visual learners. All right, that's one of the reasons I record this stuff, because sometimes people have to be beat over the head with it before it really makes a lot of sense to them. All right, but I already showed you the instructor website. I showed you that. I'm not going to show it to you again. But what I want to show you is this. I'm not going to click this, but right here, so you can always get there by Inside Rankin. Joyce Farrell has created a bunch of her own videos. So she's usually got a video or 2 for every chapter. Many of them are like 2 or 3 minutes long. Okay? And there is a student companion website. You should make sure that you click that before the end of the period, because I'm not going to give you, last semester I'd put on a flash drive the stuff, but the files that you'll need, the student data files, are out there. And I figure you're big enough, boys and girls, etc., that you can go out there and get that stuff. If you have any problems with it, just let me know. I'll be more than happy to help you with it. All right. So, this is what we talk about in Chapter 1. Again, my goal is not to read this to you. It's a typical first chapter that you see in a book. How to do this, how to do that, what's a program, what's hardware, what's software, that kind of stuff. All right? So, here are some definitions. I'll have to look. I've already got all of the tests written for this class. All of your written tests are already done. But since I wrote them a year ago, I don't remember at all what they ask. So I'll have to find that because I've got that buried in my garbage someplace online. So I'll have to find that. But as always, what we will do is at the end of each chapter, just like we had with the JavaScript book, there'll be a review questions section that we'll go over as a class. And I will have a review sheet for you, that we're going to have before you do every test. All right, just so you know that. But I wouldn't be surprised if all the stuff that you see here is on the first test. So a program, a list of instructions that tell you what to do. Many books equate a program, also known as an algorithm. All right, they equate that to a recipe. One thing I could never understand, this is not a joke, that my grandmother, who's been gone for many years, could cook anything. I always told my dad she could make dirt and she could make it taste good. It just was in her way. She gave a lot of her recipes to my mother. And I'm fortunate enough my mother is still around. All right. She's 87, and she would try her hardest, but it never tasted like my grandmother's. But the idea is if I give you a program and we type in every line exactly the same and we run it, it should always be 100% identical. Period. All right. We are going to be writing application software in here. Totally. We're not doing system software, which basically allows you to interact with the operating system. We're not doing that. We don't do anything in this program with hardware. This is about all you see with hardware. Hopefully you all understand that when you type something into the computer, in our case C#, and you go and you tell it to compile the program. When you compile a program, it's turning it into the English-like statements you put in, into the zeros and ones the computer can understand. That's what's happening. All right, that's machine language. C# is an example of a high-level programming language. So in other words, it's very English-like. Okay? There are a bunch of keywords. You'll see those as we go on in here. As far as the camel casing, you're going to see that already today. So some of that stuff I'm just blowing over because you're going to see it when we start writing programs today. All right, syntax. If you look at this, each high-level language has its own syntax or rules of the language. Well, there's syntax in that statement. There's a comma to kind of break the thought. There's a period at the end of the sentence. So syntax, basically, what the biggest syntax you're going to have in here, there's two things. Number one, C# is a case-sensitive language. So if I create a variable called age with a little a, with a little g, and with a little e, and then later I try to use it with a big A and a little g and a little e, I'll get an error. JavaScript last semester would let us do that. This is a much stricter language. That's the first thing. Second thing, JavaScript last semester, if you forgot to put a semicolon at the end of a line of executable code, JavaScript said, I'll put it in for you. Not this language. The program will blow up if at the end of any executable line of code you don't have a semicolon. All right, so that's the syntax. If you leave something off or make a mistake, when you try to compile it, you'll get a syntax error. The good news is we have a very good editor. It's actually called an IDE, or an integrated development environment, that will find those errors for you. All right, that's the good news. All right, the logic is that's what you put in. If this was real simple, anybody could do it, right? But not everybody is going to be able to go out into the real world and give it, you're given some requirements to be able to formulate in their head the logic to do whatever it is that has to be done. Okay. When you have mistakes in a program, the mistakes are known as bugs. If you want to read more about it there, you can. The idea of getting bugs out of a program is known as debugging. All right. The way that Joyce Farrell writes the book is she goes through a bunch of stuff, and then she's got a thing here that says 2 truths and a lie. So she makes this statement, and then she makes these 3, and one of them is false. Then at the bottom of the page, she always tells you which one is false. Okay? Some people learn better that way. I'm not going to go through any of that stuff, just so you know. All right? Okay. Procedural programming, that's what we do in chapters 1 through 8 of this book. So the first 8 chapters are totally procedural. When you write a procedural program, you very much tell the system what it is you want to do and how you want to do it. That's what we're going to be doing. All right? We'll use variables. If you don't know what those are, you will by the end of the period. We'll use identifiers, which are basically anything that you create. So there's certain naming conventions that you're supposed to follow. Again, don't worry about what those are. Sometimes I'll refer to the routines that we write as functions. Sometimes I'll refer to them as methods. They mean the same thing, basically. All right? When we get into chapters 9 and 10, we'll write object-oriented C. I'm not going to lie to you. Some of you will frickin' hate it. Okay? But most of the work that's done today in computers is done using object-oriented languages. All right? You will actually be using object orientation before we get into chapters 9 and 10. You just won't realize that you're doing it. All right? So they go through here some of the features of object-oriented programming languages. Guess what? It doesn't pay to go over this stuff until chapters 9 and 10. You got enough to learn. I don't want to confuse you. I will let you know if class or properties or any of these words that are in here, I will let you know what is on your written test. All right? I'll probably by tomorrow, we'll do the review for chapter 1. So you'll know. You'll have the test in front of you. Okay, so you'll know exactly what's in there. All right, so you'll know about encapsulation, about a black box, etc. People look at that and they go, I don't understand what that is. Okay? Now, if I do this, if I do a control P, right now, I'm not going to do that because there's a lot, it's just one page, I guess I could. But if I hit enter now where I click the print button, would you all agree that should print out on the printer right there? I have no flipping clue when I hit the print how that happens. I don't know. That's totally encapsulated or hidden from me. Just like when I left this morning for here, got into the car, put it in reverse. I'm not a big hardware guy. I can kind of figure out what's happening when I put it in reverse, but I don't really know. And guess what? I don't care. I do care if I put it in reverse and I go forward, but I don't care if I put it in reverse and I go backward. All right? So that's what encapsulation is. When something's encapsulated, it's hidden from you. And we'll learn about all this stuff, polymorphism, etc. All right, I'm all the way up here, the C sharp programming language. It is object-oriented, but for the first 8 chapters we'll be using it, you won't probably even realize we're using object-oriented stuff. And that's fine. I should mention, they mention this right here, and I want to show that to you, and that is, let's say that you're at home and you're really struggling with something, whatever that something is. You can't figure it out. You send me an email, all right, but it's 10 o'clock at night and I'm in bed, so I can't help you. You Google it, you can't find it. Well, the magic site here, get rid of that. Well, that was interesting. All right. The magic site, so to speak, is msdn.microsoft.com. You have to spell Microsoft right. All right. And if you can't see it, again, it'll push you off to this, but literally, that's it. And all you need is just the msdn.microsoft.com. MSDN is short for Microsoft Developer Network. All right? If you go out there, it should answer virtually all of your questions. It's got online help. In fact, if you go out and you Google something, usually one of the first results that's going to come back is something from msdn.microsoft.com. All right? When you create C# programs, you can create them in one of two ways. You're going to do both. All right? You can do a console application. You ever seen this? Anybody ever seen that? When you basically, that's a DOS interface. So if I want to clear my screen, boom, that kind of thing. That's a console application. All right. Well, we're going to do that. Plus, we're going to do what are called GUI applications, which means we're going to actually have controls. We're going to have a form. It's going to have colors and all sorts of other stuff in it. You're going to do both. Now, it says C# is modeled after C++. I'm not going to disagree with the author, except to tell you that she's wrong. All right. And that is what C# really is one of the most popular programming languages in the world right now is Java. Right? It literally is. And it's so popular that C# is kind of Microsoft's answer to Java. That's what it is. Now, if I had somebody here from Microsoft, they'd be like, that isn't right. Yeah, it is. All right. And actually, the class you take in the 4th semester is you go back and you learn how to do a lot of this same stuff in Java for the first month or two. Then you learn how to write Android applications. All right. So you're going to do stuff like this. I'm going to go over this, okay? And it may not make any sense to you right now, which is okay. All right? If I go and start up a brand new application and I call it literally first class, it's going to create that line for me that says class, first class. A class, just so you know, is what's known as a blueprint. All right? Many of you know my situation already. I've been here since July of 2016. All right? Before that, I taught at another school for about 25 years. They were assholes, so I quit. All right? I'm just being honest with you. That's kind of what happened. All right? But I have been trying to sell my house that's in Illinois on the Illinois-Wisconsin border now for about 6 months. Not a great time of the year to try to be selling a house. It's, believe it or not, a lot colder there than it is here. All right? The point is, eventually I hope that it'll sell, and now I'm talking to my wife and trying to convince her maybe we need to build a brand new house. All right? Be a smaller one. It'll probably be just the two of us unless two of my kids who are still with my wife in Illinois decide to come with us or not. But the point is this. So let's say that I decide to build a new house. And I tell the guy, say, hey, I saw this picture, and I want you to build this house for me. And it's okay. So I go there the next day, and I bought a lot, and they just start digging. They get done digging, and they start putting in bricks and all. They're probably not going to do that. The picture that I show them probably will have a blueprint with it, correct? Usually that's what's going to happen. That's what a class is. It's a blueprint from which we can create what are called objects. So this right here, that's our class designation, basically. All right? Just like JavaScript, this is a language where you put all your stuff within curly braces, just like you see right there. And when you create a console application, like the one I just showed you, every one of them will have what's called a main. Every one. All right? When we create our GUI applications, it's got a main, but you don't do anything with it. It's just created for you automatically. This literally says, print on the screen, this is my first C# program. So if I ran that, that's exactly what would show on the screen. All right? What I put in here in these double quotes, that's called a string literal. I'm throwing so much junk at you, and it, especially for the new people, it may make no sense. It should make a lot more sense when you're doing it. I can only, as the old saying goes, I can talk till I'm blue in the face. I think the guys that are in here will tell you, you learn so much more doing it yourself, whether you're doing it under my guise or you're doing it yourself. And the best thing that can happen to you, it sounds stupid, but it's not, is to when you're doing this, is to make a mistake. Because when you start making mistakes, that's when you learn. All right? If you go and you type stuff in, and this is on me, I shouldn't have done it this way, but in a lot of these tapes, if you watch my YouTube channel, I'll go and put in a 200-line program and I won't have any mistakes in it. That's not good. As you probably guessed, the first time I did that program and put in 200 lines, I had mistakes. All right? But I don't want you to spend a lot of time watching me debug. Maybe I should have done that. I don't know. What you're going to have at the top of your program is something called a namespace. You don't have to worry about it because it'll be provided for you automatically. All right? Where I showed you that line that said static void main, that's called a method header. What goes in the curly braces there, that's a method body. Okay? What's white space? Well, it's anytime you hit the space bar or the tab key or the enter key, etc. All right, so you'll learn what all this stuff is. Identifiers will do this, and then I'm going to send the two of you out. Identifiers are things you create. So if you create a variable, that's your identifier. If you create your own method, that's your identifier. If you create your own class, that's your identifier. These things have a certain type of naming convention. All right. You'll learn this as we go along. And, the reason we're going to do a bunch of programs as a class is so that you can learn the recommended naming conventions. That's all. And if I say you should do it this way, it's not because I'm that smart. But I know how it's done out in industry. I have been a programmer out in industry. All right, and that's why I'm going to ask you to do things in a certain way. Here on the bottom of page 14, these are all the key words in the C# language. I don't know how many of them there are. There's somewhere around 40. Some of these words, like go to, have absolutely no meaning. But the reason they made it a keyword is so you couldn't use it. Go to is known as the ultimate programmer's four-letter word. All right, it's something that shouldn't be used. All right. Are we going to go over all 40 of these? We'll probably hit a good half of them. All right. But a lot of them are used very, very, very irregularly. I guess there's even more. All right. So there's some on the next page too. I thought there was a total of about 67 or something like that, but I could be wrong. All right. What I like about this book is what the author typically does is she says, hey, I'm showing you how you should do things. And then she will show you not only, should you do this, but this is illegal. Why is it illegal? Because there's a blank space in it. Because that's a reserved word. Because you can't start an identifier with a number. Because you can't have a special character in there. And she explains all those to you. This is not the kind of course where, oh my God, I'm never going to be able to memorize all this. You don't have to. If you do make a mistake when you create something, our IDE, Visual Studio, will tell you. All right, just so you know that. All right, I'm going to stop it right here. And again, for the two of you, I'm going to walk you down part way. So let me take this.